3 meters to the right. And then
4 meters up.
So 3 meters to the right, 4 meters up. This is polar form. This is vector addition right here. Basically, I went 3 up and 4, or 3 to the right and 4 up. But that's not really, I haven't drawn my final vector. The final vector would be that, from where you began to where you end. So this is the answer. So if I said, what's the sum of those two vectors? Well, that's the sum of those two vectors, or this green arrow is the sum of the two vectors. That would be 5 meters long. And that angle, about 53 degrees. So I could also express this. So I express it here in rectangular form. Expressed here in green in graphic form. Graphic or graphical? Probably graphical. And then in polar form, it would be 5 meters, 53 degrees. So I have 3 different ways of expressing it. On a quiz or test, if I ask, there's some problem and the answer is going to be a vector. If I don't specify, I don't care if it's polar or rectangular.
So the top is polar form. The middle with the triangle is, you said vector form?
This is rectangular form,
Rectangular.
polar form,
Okay.
and graphic or graphical.
Graphical, okay. Graphical, and you said the top was rectangular?
Yep.
Rectangular.
Question.
Yes.
So how we actually, you wrote the meters in between the 3 and the I, so that's how like the shorthand of distance will always be.
The
Like,
short
in rectangular form, like M is for meters, and
Yes.
it's 3M I hat. So like the actual, what you're measuring in will be in between the number and the I hat, like B bar.
Oh, the units.
Yes.
Typically, yes.
Okay.
Or if you want to stick it, if you only want to write the units once, then put parentheses around everything else and put the units on the outside.
Right. Okay.
I guess if you put the M first, I'll look at it strangely and then I'll go, all right, is this actually right or not? I mean, so how old are you? Year's 29. It's just awkward.
Yeah.
Is it wrong? I don't know.
Considering doing
If somebody does it, I will
yeah.
ask, does this person tick me off with something? I don't know. I did have a student years ago who would always put his units in parentheses. So he would have written the M in parentheses.
That's awesome.
And at the time I thought, it's unconventional. I took off for it at that time. I later changed my mind on that. But yeah, try to put the units typically the unit comes after the number.
You gotta be careful with telling me what's technically right because I might do it because it's funny.
It's like radians. Radian is a unitless unit. And so technically you could add radians to the end of any problem and it's not wrong. And I had a student who took that and wrote radians at the end of every single problem.
I'm considering it. You might have to.
All right. I will regale tales of your exploits. All right. Questions? All right, 53 degrees. How'd I get that? Okay. How many of you in here had trig? Right triangle trig. Doesn't have to be fancier than that.
I think
That's putting it roughly at the half-ish. All right. There is trig in this course. It is not necessarily expected that you have had trig already. If you've had trig, you've got a slight advantage there. If you haven't had trig, we're not getting, if you took the pre-calculus trig course, you're going to go into far more depth and intricacies than we need to. We're just doing simple SOHCAHTOA. If you don't know what that means, you're about to hear it. If I have two triangles here, this is a 3, 4, 5, that's at 90 degrees, this is about a 53-degree angle, and that's about a 37-degree angle. If I have another triangle here, where that's 53 degrees, that's a right angle, and that's 37 degrees, well, if that hypotenuse is 10, what is this side? 8. And this side? 6. That the ratio of sides are proportional. If I double the hypotenuse, I'm going to double all the others, assuming that the angles are the same. This is the essence of trigonometry. Similar triangles, the sides are proportional in similar triangles. Oh, how many of you have not had geometry?
Well, I have not.
You do what, integrated math or whatever they...
I don't know if I've taken like a class that's specifically geometry.
Yeah.
Okay. At one point it was basically mandatory and required, and then at some point it became optional. I'm not quite sure what they did with geometry.
I did Math 3 2 years ago. I did Math 3 2 years ago. Does that count?
I don't know what's in Math 3. It's
There's a
that.
bit of geometry in there.
Okay.
That's not really the whole thing.
That probably. If I say similar triangles, is this vocabulary?
Yes.
Mm-hmm.
At least I got some people nodding, and other people just sort of looking at me as if I could read their minds.
I haven't taken geometry since high school. That was like 2012.
All right. Well, fortunately, it hasn't changed since then. So. All right. Similar triangles, meaning that all the angles are the same, but the sides are not necessarily the same, but they are proportional. So if I'm dealing with a right triangle, then the ratio of the opposite sides of the hypotenuse is the same for all similar triangles with those angles. So instead of course we came up with a shortcut. I say we like I was part of it. It happened long before I came along. The powers that be came up with a shortcut. They said, well, if we're talking about the opposite, so if I'm looking at this angle right here, the opposite and the hypotenuse, that ratio is always the same. Well, that ratio is 4/5. Let's give that a name, and let's call that the sine. The sine of 53 degrees is 4/5. And again, for the pedantics out there, it's approximately 53 degrees. It's not exact. If I look at the adjacent side, so I'm at this angle right here. So imagine that you're in a room with 3 corners. You're standing in a corner. I can touch 2 sides. I can touch the longest side, which is called the hypotenuse, or the side next to you, that's the adjacent one. If I look at the adjacent over the hypotenuse, that is known as the cosine. I'll write it out for those who haven't had the trig. Cosine is the word. We abbreviated to cos because INE is just too much to write. Sine, apparently we can write the I in at least, but the E is just too much. So cosine is 53 degrees. There's a couple other ones. The only other one that we are going to really care about here is if I look at the opposite divided by the adjacent, so 4/3, that is the tangent of 53 degrees.
I have a question. Why are you not using the 51 degrees?
Why am I not using what?
The 51 degrees. Because it's
This one up here?
yeah,
That's 37.
or the 37.
Well, I could. So let's take a look at that. Let's see how well this one works. Ooh, horrible. There we go. I'm assuming that you'll be able to see this color in the back. If not, let me know. I had a student years ago who only really could clearly see blue and black. So I don't know if that's a common thing or just that one student. All right, so if I looked at this angle right here, well, the hypotenuse is still 5. That hasn't changed. So the sine of 37 degrees, well, that's the opposite. This is the opposite side, which is 3/5. The cosine of 37 degrees is the adjacent of the hypotenuse. And then the tangent of 37 degrees would be the opposite over the adjacent, which is 3/4. Notice the cosine of 37 degrees is the same as the sine of 53 degrees. The cosine of any angle is equal to the sine of the complement. For those who've had trig, you might be thinking, what about the cotangent? The cosine, the secant and the cosecant. There's one problem where that pops up if you want it to, but I'm just going to ignore those for now. If those words cotangent, secant, and cosecant don't mean anything to you, that's okay. So getting to the SOHCAHTOA, the sine is defined as the opposite divided by the hypotenuse. That means the sine of some angle is the opposite side of the hypotenuse. The cosine is the adjacent of the hypotenuse, and the tangent is the opposite of the adjacent. That's SOHCAHTOA, which they came up with somewhere between when I took trig and today. Like coffee into the anticubic instead of into the hand. Happened sometimes when I was in kindergarten and today. But it makes so much sense. Questions?
What's that on the top over?
That right there?
Yeah.
It's OPP for opposite.
Okay.
Because again, writing the whole word out is just too much. All right, other questions? Because we're actually going to connect this with the stuff that we just did. Jillian, you look like you want to ask a question.
Oh, okay. I can you remind me again which one is the like on the triangle, just so I can write it down. Which is the hypotenuse is the slanting one, right?
Yeah. It's the long one or the side opposite the right angle.
Okay, and the opposite is on the bottom.
Opposite. So if you're in a room with 3 sides, opposite is the one that you're facing.
Yeah. Okay. So it'd be like okay, on a triangle, it'd be sorry,
Oh,
it'd be
you're
like
expecting me to see. All right.
this one.
That's the hypotenuse right there.
That's the okay, and then so the opposite is the one that you said.
It depends on which angle.
Yeah.
Oh, okay. So this will be the angle, right?
So that's the right angle. So opposite the right angle is the hypotenuse.
Okay, so that'd be the opposite, and then that's the adjacent.
So if you're looking at the lower left angle, the opposite side would be the vertical line you have drawn.
Okay. This one.
Yeah.
Okay, so
And
that's
if you're in the upper angle, the opposite side would be the horizontal line.
this. Okay. Okay.
It depends.
So it just depends where the right angle is.
And which angle you're talking about. Because, I mean,
Okay.
just like over here, cosine of 37 degrees is the same as the sine of 53 degrees. I mean, there's more than one way to solve these problems.
Okay. Okay. Yeah, because you can change, like you said, depending on the angle, it'll change. Okay. That's good.
Other questions before we try to connect it with the vector stuff? Let's connect. Probably not 37. Probably not all the way there. All right, so I have a vector here, called vector A, which in polar form is 20 meters, 40 degrees. I want to put this into rectangular form, where I'm going to define I hat to the right, J hat up. Because I've been brainwashed too, and that's just habit. So if I'm breaking this up, I'm breaking it up into its component vectors. And I'm going to have, so I know I'm going to the right and up, those are defined, so I'm going to have horizontal and vertical. So I'm going to figure out how far do I move horizontally and how far do I move vertically to end up at the same endpoint. You can think about it in terms of walking blocks. If I'm getting from this corner to this corner, how far would I have to go to the right? How far would I have to go up in order to get to the same spot? So I have now a right triangle here. And this is one of the reasons I hat and J hat are perpendicular to each other. If you get far enough in physics, you'll eventually deal with systems where they're not perpendicular, but that is well beyond the scope of this course. So I go over and I go up, and so now I have a right triangle, and I want to figure out what this side here is and what this side here is. And so I'm going to just come up with O, M, and Q. Because why not? Probably not N, because I'm using that for meters, so that's why not for M.
H.
There we go, H and Q. I just wanted two letters that look different. I would have gone for A and B, but I already have an A there. So I know that that's 40 degrees, that's 90 degrees, so I can figure out what that angle is. I don't have to, but what is that angle?
50 degrees?
I think it was said.
No.
15.
No, 50.
50.
All right, I'm hearing like an echo of 50. 50 what?
Degrees.
All right. If you don't give units on angles, it's assumed radians. All right. Now I can use either angle. I'm going to stick with the 40 because that's the one I started with. I know that the cosine of 40 degrees is the adjacent over the hypotenuse. Well, my adjacent side is H. My hypotenuse is 20 meters. There's my math problem. Cosine of 40 degrees, you have a calculator, use it, you can find out what it is. If you want, give me advance notice, I'll bring you tables or a slide rule.
This
If
would
I-
be degree then, because we're saying degrees.
Yes. If I'm solving for H, I got two fractions. I turn this into a fraction by just sticking it over one, because I can make anything a fraction by doing that. And so now I just cross multiply. So H would be 20 meters times the cosine of 40 degrees. And we end up with
15.3.
15.3. And that dramatic pause there is because, thank you. All right, to find Q, well, if I'm working with my 40-degree angle right here, that's the opposite side. So, well, I've got two different functions here which have opposite in it. I have tangent and I have sine. I'm going to pick sine. The sine of 40 degrees is equal to Q divided by 20 meters, where Q is 20 meters times the sine of 40 degrees. Uh, 12.6. What is it?
12.9.
12.9.
Meters.
Thank you. Now let's say that you're one of those people who just absolutely have childhood traumas from units of measure, and you try to blank it off as much as possible. If the question were, what is the length of that side? And you just told me 12.9. If it's a 10-point problem, you'd lose 3 points for not having units. Just so you know. So this vector here in polar form, I can now express in rectangular form. Let's see if we can get some stunning, well, not particularly stunning, but it is 15.3 meters I hat, because I defined I hat right there, plus 12.9 meters J hat. Graphical representation, rectangular form, polar form.
If this were on like an assignment and then we already had the one leg and the hypotenuse, do we still have to do another circuit, or can we just do Pythagorean afterwards?
Pythagorean works too. Other questions? Yes.
Going back to like if we had forgot to put the units like in the answer, would you also take points off for not having the units like while working it out?
No. At some point, I'm going to get really lax with units and just make sure they're there in the end.
Okay.
And that's the advantage of using a particular unit system. We'll be using what was considered international standard, and still is for the most part. Because if I do that, then if I know what I'm trying to find in the end, then I know what the units are, and I don't have to keep track. All right. Going the other direction. I have J hat plus J hat. To put that in rectangular form, or sorry, it is in rectangular form. To put it in polar form, well, the first thing I'm going to do is I'm going to sketch it out because I need the visual. If you can do it all in your head, more power to you. But I'm going to sketch it out. I've defined it that way, so I got 3 going to the right, I have 6 going up. And so my resultant, which is the fancy word for sum of vectors,